This video is a recap of the Visualization and Management Exercise 3 of the basics of using LiDAR data. This is part of the workshops on conservation applications of LiDAR. The instructions for this exercise can be found on the MinGeo site in the Sea House, the elevation subdirectory LiDAR page, and you use the link to the workshop training materials to get the PDF for this information. Now this particular PDF and this exercise is set up with a series of steps here we'll talk about with the display techniques, visualization, and some managing large data sets. That's what we're going to talk about. And now we'll follow along through the instructions, and we'll open ArcGIS, and within ArcGIS we're going to add the data which we had downloaded in exercise 1, and that is a particular tile, 1/16 of a USGS topo that exists within Nicollet County, and we brought down that very extensive LiDAR data set, and it contains information that is quite interesting and useful. One piece of information that was derived from the LiDAR data, the raw LiDAR data, was the contour. So the DNR processed that and has given you a contour file at 2 meters or 10 or 50 meters. So they're giving you some information already pre-calculated. They've also pulled out from the raw data just those points that are bare earth. They've pulled out any returns that are hitting vegetation or things that are above ground. And they've also classified some of the returns that they feel were hitting buildings, so that you'd be able to identify buildings within that tile. And they're providing also the digital elevation model, the DEM. Now what we're going to be talking about now is the terrain data and helping you understand the bare earth points. Now these bare earth points are very, very large. There's many thousands of them in this particular tile, so they're stored in a compressed fashion. And that is a multi-point. So if you look at the attribute table of this this layer, you'd see that 3,500 points are clumped together or grouped together, and there's 1,491 of these clumps within this this tile. And what we're going to do, if we were to select one of these records, you'd see that it would select a particular clump of these 350 records. So we've got a particular clump selected. You can see they're grouped. Okay. So now what we're going to do is we're going to use the Arc Toolbox commands within data management features to do a multi-part to single part, to essentially explode these grouped so that they're individual. And we're going to send that out. And we're going to put that within our raw data folder, our working folder, but we're going to call that single. And we'll be sending that file out. Now you'll notice when this completes that we actually only brought out one record, and that is because when we had selected the table, the bare earth points, the grouped, we had selected just one particular row, 3,500 grouped points, so that when we did the explode, we only exploded that one record into those 3,500. So what's in our final here is that we've got the 3,500 points all individually broken out. So we've got a very small subset of our original parent. Okay. Now, what we're going to do with this is we want to expose the elevation data that's within this, that's within our, with the elevation data that's within our 3,500 points. So we're going to do that by going to Data Management Fields, okay, and we're going to add a field. You can also do this by adding the field over on the table options. So we're going to add a field, and we're adding it to our single, okay, and our field name is going to be called elevation, and our type is going to be float, right? And our precision and scale, we're going to put in 18.6. We could take just the default if we wanted to. Okay. So now we've got a field added that I misspelled here, but a field for elevation. Now what we do is we right click and we do calculate geometry, and outside the edit session is fine, and we're going to calculate the z coordinate of the point. So instead of the x or the y, the east or the north south, east, west, or north south, we're going to add the elevation, which is the z value, and we're going to add the z value. So now we're going to observe that the z value is populated into every one of the 3,500 records for this small piece. Now we could have done this for this entire tile, but it would have taken a long time. So you get the idea how you can take the original data, all the original points, and examine them. It takes a long time to work with them because it takes a long time to paint. And then you could explode the detail out into a particular smaller set and examine the elevation value. Now we're going to talk about displaying information, displaying techniques. So let's add to the GIS session the demo, which is the DEM, the digital elevation model. And in an earlier exercise we talked about in properties, symbology, we talked about this idea of displaying the hillshade to show some hillshade, and that if we turned the hillshade on, and we could increase the hillshade to accentuate some of the shadows. There's also other ways that we can help display the data, and that is in terms of the stretch types, where we're taking the values that exist within this raster, and you can see the values within the raster. There's a low of 230, perhaps on some stream bed, and then there's some high bluffland or along the edges of the stream. It might be or flat areas out in the center, higher spots that are 312.68 meters above. And we could get an idea of that data by looking at the stretch and considering the histogram. So we could see how those elevation points are distributed. You get an idea that most of the points are right here around this value, which is you can get an idea of how many exist in it. Over here we're talking about an input of maybe 270. Here's down here on a stream, but you get an idea. Most of the values are out on this area that is about 300, 290, 300 meters above sea level. You can see the vast majority of the points. So you could get an idea of how this data is distributed, and you could stretch that over one standard deviation or two standard deviations, and you get an idea of how increasing the number of standard deviations you stretch it across changes its display. You could also take the mid-range, those colors in the middle of the grayscale, and you could stretch those and apply a gamma stretch that would help emphasize the shadows, the dark spots, the stretch in the dark spots, or stretch in the lighter spots. Often the gamma is positive. Where we're working with elevation, we would do a gamma of 1.5 or something like that to help examine elevation data. We might go 0.5 if we're looking at a smaller stretch, a negative value below 0. Below 1. Okay, so then we would want to talk a little bit about how the statistics are handled for this particular raster set, and most of them are we're talking about using for each raster data set. But you can, when you're doing some custom printing, when you're doing printing, you could be, if we've zoomed into a particular subset of this area, say we're just looking at this stream, we could be stretching it just for that display extent rather than the entire for the raster data set. The other thing that we could do is we could, in custom settings, we could save the XML. We could save these statistics, and then if we were displaying some other raster, we could be bringing in those statistics, so we're using the same the same statistics as we're stretching them over the same range, so that we would be able to compare the images, the raster layers, side by side. So you could save that XML, and then you could load that to another image, to another surface, and you get the idea of how you can manipulate these. The most common are the statistics, or the minimum, maximum, and the histogram equalize. So you're using the histogram to equalize it, or the minimum, maximum, and occasionally you're able to, you actually could want to edit the values. If you're doing minimum, maximum, you could stretch over more extreme values or tighter values if you wanted a different sort of stretch effect. It's all about how you display the data. Now, the next thing about display that we want to talk about in properties symbology is how the colors are displayed. We're using the color ramp, a simple gray color, and we could invert that. To turn it around the other way around by using the invert option, or we could select a different color ramp that goes from light to dark and instead of dark to light. Right? And this might help us understand the features. The other color ramp that's very useful in elevation data is where it's multicolor, where there's a continuous scale and it changes. So the very high values would be white and the very low values would be this light green. And I'm going to change the standard deviation here to 2 and apply. And you'll get the idea that this helps you understand some of the data a little bit better. Okay, you can see now the reason for that white line was that I had a custom setting, so I was stretching for a particular area over a different range. So I turned that off. I said for each raster data set, and clicked apply. So this is a common way of displaying DEM data. Now the next thing we want to talk about is Hillshade. Is to actually, instead of just displaying the shadows as a hillshade in symbology, we're actually going to our toolbox and we're using a calculation within the spatial analyst tools, right? And you want to make sure the customize extensions are turned on, so spatial analyst is turned on to get these tools to work. But in spatial analyst, we want to select surface and hillshade. And here we're going to create a new surface rather than just display the DEM with some shadows. We're going to create a new surface from our DEM, and we're going to call that Hillshade. And now we can control where the sun is and how high the sun is above the horizon. So in this case, the sun's at 45 degrees, halfway up the horizon. And that the sun is at 315. So we could change this to some other location. We could move it to 270. We could move it to due south at 180. You get the idea of how we would move. We also could model the shadows or accentuate the shadows. Move this number to 2 or 3 or 4 or double. We're just going to take it as is. And when that's done, you'll see that layer on top of your DEM. So what's often done is that we go to Properties, Display, and we change the transparency to something like 50%, so that we're able to not only display the DEM with our colors, showing the colors where the very high is the white and the low is this light green, but we've given a type of emphasis to the shadows and showing the hillshade in sort of a bas relief type of fashion. Now the next thing we want to talk about is actually displaying this over image data. And what you're going to want to do is you'll want to use the MinGeo site, and on the MinGeo site in the folder WMS there is information about how to access imagery, and there's some technical specs that you could access from MinGeo, and you could highlight this WMS, and you would include that in when you're adding GIS data. If you were to add a GIS server and add a WMS server, you could fill that link that you copied from the MinGeo site into that location to establish that GIS server. And I've already established the MinGeo website, and I've established the MinGeo website already linked, so that now I've brought the aerial imagery from the MinGeo through the WMS process online. So I've sort of streamed them as I need them. And all this information, all these images are available to you throughout the state of Minnesota. Now, all we're concerned about is our particular area. And you'll notice that this picture is on top of our our DEM or our Hillshade data. So there's a trick that we can use to try and view this if we're establishing our DEM as our a reference layer. This is the display, the effects toolbar, so that if I'm in toolbars, options, if I have effects turned on, which is this effects toolbar, I'm able to do a swipe. And for example, here I can turn on the MinGeo, and that I can swipe that across and move the DEM and swipe that. Now you'll notice I was not swiping that because I had the aerial photographs above, and I'm swiping the DEM. So you can control what you swipe, all right, and on top of what. And the image has to be on the bottom to have the swiping work. So I'm going to swipe my image either up and down or sideways to move whichever way I want. But you get an idea how you're able to reveal the information below. And you can see the power of viewing the image with your DEM data or your Hillshade data on top of it. Now I have my Hillshade turned on, so that's what's showing. So I'm going to swipe it, and you get an idea of how you can turn this on. And you can see what's represented in this digital elevation model and compare that to the ground points presented in the... Now you'll notice I was swiping down. I could also swipe from the side. Oops. I want to move over from the side and swipe the arrow. So you can either go up or down. The important thing is to remember what you're swiping, and you have things stacked in the right order. Now the next thing that we want to talk about is how to deal with all this data. Now we talked about when we're painting the bare earth points, it takes a long time to paint, and because these files are huge. So what we want to do is to make sure that when we're at this scale, we're not showing too much detail. So how you do that is within the properties, within the General tab, okay, we're able to control the scale at which. So don't show this layer when we're zoomed beyond a certain point. So if we're very close to the ground, we're only going to see a few points. Maybe at 1,000 or 10,000, we would show this, and so that this particular layer, which is we're at 1 to 24 right now, this layer is not going to be visible, so that we would be able to. But if we zoomed in to something that was under that 10,000, we would be able to have those points show up. And there it makes some sense because we're at a very, very large scale. So the painting the points is not an issue because we're only showing a very small part of the ground within our view. There's a host of other tips within the PDF file that are also very useful to work with large data sets. The first one is to get a CPU that works quite quickly. I'm running on a 4-processor machine right now. I'm using the newest version of Windows, so I could have quite a bit of RAM available, and very high-speed disks. I'm working locally. I'm not running over the internet, and those types of things. And there are a number of tips that you could work on about calculating pyramid layers and calculating statistics that would be helpful to speed it up, and and as well as the tips that I was just talking about the zoom, of turning things on only when you're able to see a lot of detail. You're not trying to show a lot of detail when you're at a very, very small scale, like the whole county or a whole tile. So there's a number of things that can help you. And the last one is very useful when you're working with the MinGeo data for the state, is to make sure you turn off the imagery so that you're not constantly bringing that down while you're working. So that's the last tip on that side. Now the next tip is divide up. We've already talked about the idea that the LiDAR data as it's delivered is broken up by county, and then broken up by topo by 1 to 24, and then broken up by the within the topo into 16 tiles. And you probably want to just use the minimum amount of data and divide up and conquer, essentially, as we're talking about. Work on small areas. The other very useful idea is this sort of batch processing idea outlined in our handout, and we've got some examples. We have some examples for you that if you're using a particular tool, after you've gone through and worked on a small area and you want to perform an operation like clip, or you're doing other operations, if you right click, okay, instead of just click on it and open it, if you right click, you could go to batch, where you would be able to establish clipping many different. So you would add the various different rasters and set up your environments, and then handle 15 tiles all one after another. And that batch processing might very well help you run through a whole series of steps. But the important thing is that you do it once and you get the hang of it, and you understand where you're putting it, and you're using some logical organization and file names, and then you begin to set up the batch run where you're doing all the tiles within a 1 to 24. You're breaking them up, you're doing your detailed calculations in batches. This ends this video.